Hello everyone, welcome to my channel Abhilash 2021. In this video, we are going to discuss exercise 1.4 of chapter 1 real numbers. So the first bit is without actually performing the long division, state whether the following rational numbers will have a terminating decimal or a non-terminating repeating decimal expansion. So in this first bit completely we have 10 questions. So let us discuss one by one. Here the first question is 13 divided by 3125. So before going to solve this one, let's have a small discussion about when we will say a rational number has a terminating decimal or else when it will be having a non-terminating repeating type of decimal. So for this we need to concentrate only on the denominator. If the denominator is in the form of 2 power n into 5 power m. I repeat, if the denominator is in the form of 2 power n into 5 power m, then the rational number has a terminating decimal, otherwise non-terminating recurring decimal, recurring repeating, both the words are same. So I repeat again, if the denominator is in the form of 2 power n into 5 power m, it has terminating decimal, otherwise non-terminating recurring decimal. So what exactly this 2 power n into 5 power m? Let us make it more clear. In the denominator only number 2 should be there. Otherwise only number 5 should be there. Otherwise both 2 and 5 should be there. In the denominator only number 2 should be there, otherwise only number 5 should be there, or only 2 and 5 should be there. If these are there in the denominator, then we will say that the p by q number has terminating decimal. Except this 2 and 5, if any other number is there, then immediately we can say that it has non-terminating recurring decimal. So two things we need to remember. The first thing is the denominator should be checked after prime factorization, and the second thing is we need to check for every question whether the cancellation or simplification is possible or not possible. So let us check one by one question so that you will get perfect clarity about this one. Now I don't have any work with the numerator, so just write the numerator as it is by, in the denominator we have 3125. So that is not a prime number, so we need to do prime factorization. 3125 prime factorization. Last digit is 5, so definitely it will come in 5 table. 5 6 are 30, 1 will remain. 5 2s are 10, 2 remains. 5 5s are 25. Here again last digit is 5, so again it will come in 5 table only. 5 1s are 5, 5 2s are 10, 5 5s are 25. Again the last digit is 5, 5 2s are 10, 2 remains. 5 5s are 25. Finally again 5 5s are 25. So completely how many times we got 5? 1 2 3 4 5. So 3125 is nothing but 5 power 5. Now if we observe, in the denominator only the number 5 is there. So 13 by 3125 has terminating decimal. Here we need not to worry about the power also, even just the base only we need to check. Power we don't have any work, only the base, whether base is 2 or 5 or both 2 and 5. Coming to the second one, 17 by 8. The numerator 17 as it is divided by 8 can be written as 2 into 2 into 2. 2 to the 4, 4 to z. So 17 by 2 can also be written as 2 power 3. So here 2 is 3 times, so I wrote it as 2 power 3. Now if we observe this base, in the denominator the base is only 2. So again it will be having terminating decimal. Again I am saying only 2, only 5, otherwise both 2 and 5. Coming to the question number 3. 64 divided by 455. Here the denominator is 455, right? So for 455 let us do prime factorization. Last digit is 5, so it will come in 5 table. 5 9s are 45, 5 1s are 5. 91 will come in 13 sevens are 7 ones are 7 as usual. So 64 divided by 455 can be replaced with 5 into 13 into 7. Now if we observe this clearly, in the denominator except 5 we have number 13 as well as number 7 also. So as I said in the previous case, except 2 and 5 we don't want any other number at all. But before that we need to check once whether any simplification is possible or not. In 7 table 64 won't come, in 13 table also 64 won't come. So simplification is not at all possible. Now I can come to the conclusion that in the denominator except 5 some other numbers are there, otherwise except 2 or some other numbers are there, otherwise except 2 and 5 some other numbers are there. So we can say that it has non-terminating. But in the exam we cannot write like that. In the denominator except 5 some other number is there, in the denominator except 2 some other number is there. If we write like this means it won't make any sense. So that's what we need to write is it is in the form of 2 power n into 5 power m, otherwise it is not in the form of 2 power n into 5 power m. That is the good thing. Next let's move to the question number 4. Question number 4 we have 15 divided by 1600. So let us do prime factorization for this denominator 1600. Last digit is 0, it will come in 2 table, 2 8s are 16, 0 0 as it is, 2 4s are 8, 0 0 as it is, 2 2s are 4, 0 0 as it is, 2 1s are 2, 0 0 as it is, 2 50s are, 2 25s are, 5 5s are, 5 1s are. So completely how many times 2 is there? 1 2 3 4 5 6. So 15 divided by 2 power 6 into 5 is there 2 times, so 5 power 2. Now if we observe this denominator bases, here 2 is there, here 5 is there. So except 2 and 5 there is no other number in the denominator. So 15 by 1600 has terminating decimal. So we will write it as the denominator is in the form of 2 power n into 5 power m. So it has a terminating decimal. Next moving to the question number 5. 29 divided by 343. 29 by 343 is a cube number directly, so that is 7 cube. So here anyway 7 table 29 won't come, so cancellation or simplification is not possible. Then we can conclude that the denominator is not in the form of 2 power n into 5 power m. So otherwise in our words if we speak, in the denominator except 2 and 5 some other number 7 is there, which is not at all necessary to us. So definitely we can say that it has a non-terminating recurring type of decimal, otherwise non-terminating repeating decimal. Repeating, recurring, both the words are same, so don't get confused with that. Next question is 6th one. 23 divided by 2 cube into 5 square. Now here if we observe the denominator, we don't have any problem because already he gave the prime factorization of the denominator, thank God. No need to solve this again then. So anyway we don't have any work with the numerator, so numerator as it is I am keeping just. Now if you observe the denominator 2 power 3 and 5 power 2, both the bases are 2 and 5 only, no other number except 2 and 5. So I can say that the denominator is in the form of 2 power n into 5 power m. So it has terminating decimal. Next, question number 7. 129 divided by 2 power 2 into 5 power 7 into 7 power 5. Here in the denominator 2 is there, 5 is there, which are necessary for us, that is very good. But some other number 7 also there in the denominator, so which is not at all necessary to us. So And before going to the conclusion, I need to check whether any cancellation or simplification is possible or not possible. In the denominator we have extra number 7, right? And in the numerator we have 129. Let us check in 7 table 129 will come or not. Of course it won't come. So no simplification or no cancellation possible. That 7 will remain like that only, the denominator. So now I can say that the denominator is not in the form of 2 power n into 5 power m. So it has non-terminating recurring decimal. Coming to the question number 8. 6 divided by 15. The numerator 6 as it is divided by 15, denominator can be written as 3 into 5. Now if you observe the denominator, here 5 is there, that's okay, but extra other number 3 is there. So before going to the conclusion, I need to check whether the simplification is possible or not. Here 3 1s are 3 2s are. So our final answer remains with 2 divided by 5. Now if we observe keenly, here the denominator has only one number, that is 5. So the denominator is in the form of 2 power n into 5 power m. So it has terminating decimal. In the exam you need to write that sentence clearly. It has terminating decimal, otherwise it has non-terminating recurring decimal. And before that, reason. The denominator is in the form of 2 power n into 5 power m, or else the denominator is not in the form of 2 power n into 5 power m. Coming to the question number 9. Here the question number 9 we have 35 by 50. Wow, very simple. 35 by 50. 35 I don't have any work with it. 35, so I am writing as it is, divided by 50 can be written as 5 into 5 into 2. 5 5 is 25, 25 is to the 50, correct. So now here in the denominator only 5 and 2 only there. So this is terminating decimal. In this question, simplification also possible. If you do simplification also, in the denominator you will be having either 2 or 5 or both 5 and 2 only. So definitely it will be having a terminating decimal only. Coming to the last but not the least, 77 divided by 210. Now let us check clearly. 77 as it is divided by 210 can be written as 7 into 30. So 30 can be written as 5 into 6. 6 can be written as 2 into 3. So 7 5 is 35, 35 2 is 70, 73 is 200. So actually I am little lazy to write this prime factorization always. So that's why I am going with this direct method. But don't think like that actually. If you are also writing like this only, it will become habit, so that in the exams you can able to finish it in less time. No, it's a small number or else even it's a big number, every time I will do prime factorization means that's very good, because we won't do any mistakes, but it takes a bit more time, especially for the objective questions. So that's why sometimes we need to have a little confidence on ourselves, and sometimes we need to do this kind of experiments also. That is, without taking a rough part, we need to just do it. Now in the denominator 5 is there, 2 is there, which two are necessary for us, so okay. But here some other number 3 is there, and here some other number 7 is there. So first we need to check that those two are not necessary for us. So any simplification is possible or not possible, we need to check. So let me go with this 7 table now. 7 1s are 7, 7 11s are, thank God in the denominator 7 gone, but still the denominator 3 is there. So 3 I cannot do any division or simplification, nothing. So finally I remains with 11 divided by 5 into 2 into 3. So now except 5 and 2, some other number 3 also there. So that's why we will say that it has non-terminating recurring decimal. Coming to the next one. Till now you listen to my video, right? If you feel that you understood something from my lecture, please subscribe to my channel and immediately share the link to your friends so that they can also enjoy my video. Now the second bit is write down the decimal expansion of those rational numbers in question 1 above which have terminating decimal expansion. In the above one, where terminating are there, man? Oh my god, do I need to check all these things like this? Means it's very difficult. Okay, thank god, first question I have 13 by 3125. Okay, the first question is 13 divided by 3125, which is equals to the numerator as it is divided by, for the denominator we need to do the prime factorization, right? So 3125 can be written as 5 power 5. This prime factorization already I did for the first bit, so if you want, just you can skip it back. So now the question is, if it is a terminating decimal, then we need to find out the decimal value for that. So here 31 by 3125 has a terminating decimal, so we need to find out the decimal point for that. So first the denominator you write it in the prime factorization. Then here the denominator is 5 power 5, right? So you need to multiply and divide by 2 power 5. If 5 power something is there, means you need to multiply and divide by 2 power. If 2 power something is there, means you need to multiply and divide by 5 power. Just remember, 2 is there means 5, 5 is there means 2. If 5 is there 4 times, compulsory 2 should be there 4 times. If 2 is there 10 times, 5 also should be there 10 times. 5 and 2 should be there with the same power even. Okay, now the numerator if we observe 13 as it is into 2 power 5, 2 into 2 into 2 into 2 into 2, 32 by 5 power 5 into 2 power 5, that is 10 power 5, which is equals to 13 times 32. (416) divided by 10 power 5 are the 5 is there, right? So keep 5 zeros, 1 2 3 4 5, that is equals to, write the numerator as it is 416 from the right side. Here we have 5 zeros, right? So from the right side count 5 digits, 1 2 3 4 5. So now keep the decimal. So the answer is 0.00416. Next question where we got the terminating one is 17 divided by 8, which is equals to numerator as it is 17 by denominator 8 can be written as 2 into 2 into 2, that is 2 cube. Here in the denominator we have 2 cube, so we need to multiply and divide by 5 cube. That is equals to 17 into 5 cube 125 divided by 2 cube into 5 cube 10 cube 125 into 17. It is 2125 divided by 10 cube, power 3 is there, so 3 zeros, 1 1 2 3, 2125 divided by 1000. First write the numerator as it is 2125 from the right side after 3 digits, 1 2 3, so the answer is 2.125. Next question is question number 4. 15 by 1600. So this 1600 again I cannot do prime factorization, so I'm just moving to the previous bit so that I can copy that. Okay, here 1600 we have, right? So that prime factorization is 2 power 6 into 5 power 2. 15 as it is by 2 power 6 into 5 power 2. Now observe here clearly, in the denominator 2 is there 6 times, but 5 is there only 2 times. Papam, that 5 needs still 4. So into 5 power 4 by 5 power 4. Already in the question itself 5 is there 2 times. Now I am giving 5 4 times. So total previously 2 times. Now I gave 4 times, so total 6 times. Already in the question itself 2 is there 6 times. So now 2 is there 6 times, as well as 5 is there also 6 times. So 15 into 5 power 4, 5 into 5 into 5 into 5, that is 625, divided by, here 2 is there 6 times as well as 5 is there 6 times, right? So 2 power 6 into 5 power 6, 10 power 6. Coming to the numerator, 15 into 625, that is 9375, divided by 10 power 6, right? So just 6 zeros, 1 2 3 4 5 6. So what it will become then? Write the numerator as it is 9375 from the right side after 6 digits, 1 2 3 4 5 6. So the answer is 0.009375. Next, coming to the next question, that is question number 6. 23 divided by 2 cube into 5 square. Here the denominator itself is a prime factorization, so no need to worry about that one then. So here observe clearly, 2 is there 3 times, but 5 is there only 2 times. So one more 5 is required, right? So that's why multiply and divide with the 5. So that is equals to 23 into 5, that is numerator, 115, by 2 cube into 5 cube, 10 cube, that is equals to 115 by 10 cube. So 3 zeros, 1 2 3, equals to, write the numerator as it is 115 from the right side after 3 digits keep the decimal 1 2 3 dot here. So 0.115. Next, question number 8. The question is 6 divided by 15. So that is equals to 6 by, the denominator 15 can be written as 5 3s are, 3 1s are, 3 2s are. So finally we remains with 2 divided by 5. In the denominator 5 is there, so we need to multiply and divide by 2. 2 by 2. That is equals to 2 2s are 4 by 5 2s are 10. What is 4 by 10? It's very simple, 0.4. And the last one in that is 9th question. That is 35 by 50. This is very simple. See, 5 7s are 35, 5 10s are 10. Sorry, 50. So we remains with 7 by 10. 7 by 10 answer is 0.7. Coming to the bit number 3. The following real numbers have decimal expansions as given below. In each case, decide whether they are rational or not. If they are rational and of the form p by q, what can you say about the prime factors of q? So actually in the rational numbers, we have two types of decimals. One is a terminating type of decimal and the another one is non-terminating recurring type of decimal. So this terminating is nothing but after the decimal, if the digits are stopping or ending or terminating, those kind of decimals all comes under terminating. And after the decimal, if it is not at all terminating but it is following some particular pattern, it is repeating continuously, that comes under non-terminating recurring type of decimal. Now let us check one by one question and let us decide that. Here if you observe this question properly, after the decimal 1 2 3 4 5 6 7 8 9, it is stopping, ending. So this is a terminating kind of decimal. So if it is a terminating kind of decimal, then definitely it is a rational number only. Now he is asking, if it is a rational number, then it can be able to written in the form of p by q, right? Then after writing p by q form, then what will be the q? So it's very simple. 2, 5, right? Yes, because already we know that in the denominator, if 2 or else 5 or both 2 and 5 are there means, then definitely it will be having a terminating decimal. So it has terminating decimal means, then definitely the prime factors of q are 2, 5. Next, 0.120, here 120, 1200, 12000, 1 to 4 zeros and so on. Here, first of all, this is not terminating because it's not ending or not stopping. So I can say that non-terminating. Non-terminating. Then, is it repeating? No, not at all. Because 120, 1200, 12000, 1240, as it move on, keep on moving, then it is increased by one digit always. So it is not at all repeating also. Non-terminating as well as non-repeating. So if a decimal is non-terminating as well as non-repeating, then that comes under irrational number, neither terminating nor repeating type of decimals. Next, 43.123456789. So this bar indicates that these many digits are repeating continuously. So it first of all is non-terminating, because those are repeating means not at all stopping. Non-terminating but repeating. So non-terminating repeating decimals comes under P by Q form, but it is non-terminating repeating, right? So compulsory the denominator won't be in the form of 2 power n into 5 power m. Thank you.